All right, let's get going. How's everyone feeling? Good. We good to go? Good to go. Cool. Hey, my name is David, for those of you who don't know me already, and I'm sorry that you know me if you do know me. Today's talk is going to be about authorization for a change. It's all about it. I had a hard time saying the title because I really want to say don't ask for permission, ask for forgiveness, because it's so ingrained. But today it's the other way around. Don't ask for forgiveness, ask for permission. I'm the CTO at a company called Axiomatics. We do authorization, blah, blah, blah. We're on the show floor if you want to come see us. We're obviously the best authorization company there is. And on that note, they're everywhere. It's a really scary world out there, really dangerous. They're out to get you, every single one of you, and me. They look innocent, like not scary at all. They look very normal. They will drain your bank account. I think this morning the person from, was it National Australia Bank, was talking about the multi-million-dollar type fraud. Yeah, that's scary. It's a good thing I don't have $1 million in my bank account. They will, speaking of authentication and sessions and whatnot, they will gobble every single cookie you have. And they won't even ask for permission to do it, of course. Can anyone guess what type of threat actor I'm talking about? Chicks? That works, yeah? They don't eat cookies, though. I mean, they can, but not always. Cookie Monster is a good one. He doesn't drain your bank account, though. Kids. This is my daughter. She just turned 4, and she has a very weird conception of authorization. She will ask for permission after she's done it. And I think it's kind of my fault because we played this little game of, you shouldn't eat the chocolate, hee hee ha ha. And of course, when I turn my back, she eats the chocolate and she thinks it's very funny. So in this particular instance, we went to an ice cream parlor to eat ice cream up in Vancouver. And so I buy the ice cream, I give it to her, I turn around to like tap or do whatever it is, and turn around again. She'd already started eating the ice cream. I didn't even say go. Like she just went off and ate the ice cream. Fortunately, I can tell her to stop. I can also scold her for doing it, and she will get a tummy ache. So the correlation between doing the wrong thing and feeling bad is, like in kids, is very, very, there's a very quick feedback loop. So that being said, I'm here to talk about authorization models and what has been, not wrong, but what has been limiting in the past, if you will, with authorization models and what we need to address moving forward. So if you go back to like the 70s, when Jeff was like 20 years old, I guess, in the 70s, or 20 months old, kidding. We had access control lists, right? And if you look at the definition of access control lists, and if you look at the underlying models that were being proposed back in the 70s, DAC and MAC, they were defined by, I'm not quite sure if it was DoD, but it was DoD related, mandatory access control, and yeah.
Beyond the academics.
Yeah, so, well, we'll get to that. So that's the stuff that we had to do, and I like to call it identity-centric because it really just focuses on the user, right? It doesn't really look at the rest of the data. And then moving forward to 1992, when Jeff was a little older, we had RBAC. And of course, RBAC sort of existed before 1992, but NIST formalized it in a paper in 92, and then everything built on top of that, identity providers, user management products, and so on and so forth. RBAC is a really great way to scale your ACLs, really. So instead of saying, I'm going to give Joe access to this thing, I'm going to say, I'm going to give managers access to this thing. So you're moving away from just the individual. So RBAC was a pretty good model. And then, of course, we have relationship-based access control, or RBAC. I don't remember when that was formalized. I want to say it was 2015-ish or 2005 when the paper came out on relationship-based access control. Then we have ABAC, attribute-based access control, which is also pretty old, formalized by NIST in 2013. And it's all about saying, it's not just about a role or a group or a user identity. It's about any number of labels or attributes that can describe different things. And then there's more models we can think of. Zanzibar is a model that Google wrote, which is kind of ACL-like with additional things. So that's 2019, if I remember correctly. So these are the different authorization models that we're dealing with, and they all have pros and cons. They have their limitations, their benefits, of how easy it is to administer and where they shine. But we can actually group them into different phases of authorization. And that's actually, like for me, this is really important because I'm an ABAC guy, so I think everything should be ABAC. It's actually not that simple. I also think everything should be MAC, but it's also not true. Like, you do want to have discretionary access control. I do want to be able to share a document with you, Greg, and there's no policy about that. It's just individual access. But the reality is we can group authorization into 3 buckets. Admin time, and RBAC belongs to that. You could argue that potentially ACL sort of belongs to that. You have runtime authorization. If you look at zero trust literature, you'll see they have something called continuous access. This is where runtime authorization kicks in. And sorry, rewinding back to admin time, the reason we call it admin time is that the authorization happens at admin time, meaning when you join a company, you're given permissions, entitlements, roles. You're a manager in a team. We're going to give you these entitlements. And when you log in, you get those permissions inside of your session, inside of your token, whatever it may be, right? It's admin time. Runtime is very much about as you try to do something, there and then we're going to give you access or not give you access. But there's another phase called event time that Ian Glazer wrote about in a blog post, and that my peer in the Auth-Zen working group, Atul, I'm not going to pronounce his last name, it's too long, wrote about. And that's event time, being able to use signals, being able to listen to what's happening, being able essentially to say, well, you have a token, it lets you do this much, but now I just learned that your device is compromised, so let me just send a signal over so that your token can be retrofitted to fewer access. So that's event time authorization. And I realize I just summarized all my slides, so thank you very much. But joke aside, admin time, you assign users the roles and entitlements that you want them to have. It tends to be a permissive model only, no joke intended, in that with admin time authorization, you just tell what people can do, but generally you can't tell what people cannot do, right? You punch holes into what they can do. It also requires, if you do that, and which is the model that we've all been using for the past 20 years, you have to have a good joiner, mover, and leaver process, because otherwise you accumulate permissions that you shouldn't have. So the company I'm at, we're about 60 employees. I left and came back. But I still have permissions from 2010 when I joined, which I probably shouldn't have, especially for an authorization company. So if you don't have a good joiner, mover, leaver process, these things happen. And it's very easy to forget. Speaking of forgetting, someone during one of the keynotes said, you lose track of all the entitlements that you've been defining over time. I think it was Pam probably that said that in her presentation. So when you have admin time, you need governance on top of your roles, your identities, the assignments, the deprovisioning. You have to have that. And it leads to, if you don't have that, it leads to a lot of issues like broken access control if you look at the OWASP threats, or misconfiguration. That's another threat on the OWASP list. Now, given that I was, using my daughter as an example, we've been reading a book called If You Give a Mouse a Cookie. Has anyone read it? Yeah? I was going to say it's horrible. It's a great book, but it's horrible. It's a loop. Like, when we read it, it's never ending. It really is never ending. So if you give a mouse an OAuth token, then they'll just keep using that OAuth token. They'll ask for more. And I'm saying OAuth token because in my mind, OAuth tokens are very much session-based. They're very much RBAC-based, if you will. And like my feeling, this is my personal view, and if there's anyone from IETF OAuth in the room, please don't hate me. But it feels like we're trying to use OAuth tokens for the wrong things sometimes. We're trying to make it do dynamic authorization and runtime authorization when it can't really, or it's not very well done for that. Thank you, Sebastian. And that leads to things like access creep and token bloat, because what you're really trying to do is address dynamic authorization, but still using an RBAC model, because OAuth is pretty much just an RBAC model in a new shape and in a more federated way than just a single environment. So that's not good. Right. So new times require new techniques. There's zero trust, of course. If you look at all the literature written by the US government, DoD, and other places, NSTIC, NIST on zero trust, they do talk about continuous access and being able to verify always and never trust. They talk about principle of least privilege as well. Well, why should you be given all these entitlements or all these claims when in fact all you need to do is this now and then later that, right? There is a lot of good material that I recommend you go check out. I'm not going to read every single one of those links. But the bottom line that you want to remember is that it brings out a new architecture. We call that the P*P architecture, as in PAP, PEP, PDP, PIP. And we call it P*P as opposed to the AS/RS, so authorization server / resource server architecture that you have traditionally in the OAuth world. And what we're trying to figure out now, we collectively, the identity community, is how to bridge the two worlds together. So we had a great session by Yves Mailer at IW back in October, so 8 months ago or so, about how to marry the two worlds together. In the P*P model, it's the model that you'll find in ABAC, in NIST ABAC. That's the architecture that they have. It's the model that PBAC and Graph products all use to some extent. It is the model that right now we're recommending within the OpenID Auth-Zen framework, but that will change as we try to sort of get along with the OAuth world. And the way that it works is pretty simple, in theory. You have a pointer somewhere. Oh, never mind. You have a client or a user or a service on the left-hand side. That client or user or service, it wants to access a resource on the right-hand side. And what you do is you're going to deploy an interceptor in the middle, a PEP, policy enforcement point. That interceptor in the middle will go off and ask an authorization service, a policy decision point, hey, can the user do this? And the policy decision point will look at its configuration. And I say the word configuration because in my world it would be a policy, but in other people's worlds, in graph land, it could be a graph. In Zanzibar land, it could be tuples. It doesn't really matter, right? There's configuration behind the scenes. So the PDP looks at the configuration and it says, oh, yep, you have access denied or access granted. I'm going to return that back to the PEP. The PEP enforces the decision, hence the name, and access is either permitted or denied. Pretty straightforward, right? Well, no. What if your app is Salesforce or any SaaS? What if your app has, as an interface, a web UI? How do you do a PEP for web UI? You're going to be parsing HTML? I mean, that's fun, isn't it, right? Marquee and so on and so forth. So it doesn't really work all that well. So this architecture is fantastic if you have a good way to intercept. So think about that, okay? And then in my particular case, I use Alpha as a means to configure the system. Alpha is the standard for authorization policies. Now, with Auth-Zen, what we're trying to do is marry the different approaches, right? Question, has anyone heard of Open Policy Agent? Most of you, right? So Open Policy Agent is a CNCF project for pretty much authorization, historically focused on infrastructure, but it could do everything. It doesn't have to be infrastructure. And they also have a PEP PDP principle, so fine. However, their interface is different from the interface that I use in Alpha land or in Zacmo land. So what we decided in Auth-Zen is let's get together, let's look at the differences, and let's just make sure that we can all interoperate. So I can send a request from my world to Open Policy Agent, and Open Policy Agent can send a request from their world into my world, and it's going to work fine. So it's very much about interoperability on the PEP PDP interface, number one. Number two, about design patterns, knowing how to do authorization, so the P*P or the token-based approach. And number three, it's about education. A lot of software developers still do not know that you should not be building authorization, that you should be externalizing authorization. Like, who would dream of building authentication today? No one, right? Hopefully. But authorization, it's still very much, because it's kind of like in the middle between identity land and application land. It's this sort of very uncomfortable musical chair thing that you're playing and you're stuck in between two chairs. That's why we need to do a lot of education. If you want to join Auth-Zen, please do. It's OpenID. It's only $50 a year to be a member of OpenID. We're doing a readout of Auth-Zen tomorrow. We did an interop yesterday. So please join. Now let's look at what it looks like in real life. This is what a policy-driven approach to authorization would be. So instead of thinking in terms of roles or entitlements, you just think in terms of plain old English. A manager can view a bank account. A manager can view a bank account of a customer in the same branch. A customer can view their own bank account. A customer can view the bank account of a dependent, maybe a senior parent or a child or my kid to make them pay for the ice cream that they ate before I told them they could eat it. And this is just plain old English, right? It's not rocket science. One of the biggest hurdles I see in the world of authorization is that we collectively are so used to thinking in terms of roles and role engineering that we really want to do roles. But no, let go. Let go, Luke. Do proper policy. This is what it looks like in code. This is the alpha example. I'll have an example later comparing Rego, Cedar, and alpha. But as you can see, I think anyone can read this and understand what it does. Here we have a policy that focuses on accounts. And inside of that policy, I have another policy that focuses on viewing accounts. And that policy contains a reference to a policy called manager, which allegedly is in another slide that I deleted, so you can't see what that says. But you can imagine that it says user.role is equal to manager, and access is permitted. It's pretty simple. It's not rocket science. And by the way, when I was talking about the different authorization models, I'm not pitting them one against the other. You need them all to some degree. You need RBAC. You need roles. They're good. I mean, we have to structure people. There's, managers, janitors, contractors. So we need the roles, and they're used in the policies. It's just that you shouldn't be using roles for what they're not meant to be. Much like I could probably write an access control list in a policy, but that's not good use of a policy. You should store an access control list in Zanzibar, maybe, or in a simple database. So use the right authorization model for the right use case. If we compare the policies side by side, this is what they look like. They're actually not the same. I don't think they're not the same use case. So apologies about that. But on the left, you have Rego. Rego is the language that Open Policy Agent uses. What is really, really great about Rego is that it can do everything and anything you want it to do. What is not so great about Rego is that it can do everything and anything that you want it to do. It's a full-blown programming language. It's based on data log, which I'm sure is great for what Rego wants to do. But if you've never done data log before, or Prolog, or any one of those languages, it's kind of messes with your brain. It's not very good. But the problem with Rego is that it's very hard to audit eventually. Because it can do everything and anything, how can you do access reviews on that language? How can you do audits on that language? It's like trying to do audits on Java or C++. It's really, really hard. So then you have alpha. Alpha is more constrained. It can't do everything by design. It's focused on authorization by design. The syntax is relatively easy to read and understand, and it has a hierarchy. So you can nest policies. You can build a hierarchy that reflects your business. So it works pretty well. And yes, I'm biased. I'm in love with alpha. But actually, there's one thing it doesn't really do well, like I said, access control lists, but also relationships. If you wanted to say, oh, I own this document, therefore I can see the document, we actually have to write a policy for that, whereas some languages and some techniques, especially graph-based authorization, can just do that naturally because they have the data model to express it. So one of our peers, Alex, is in love with graphs, and if he were here, he would say, don't do alpha, do graphs. Oh, he is here. Damn. Damn, burned. Does my wife know about Alex? About what?
That you're in love with alpha.
Oh, she does. She knows the order in which things go. My kids too, by the way. His wife knows about graphs too, by the way. And then there's Cedar, which is something came out a year ago, AWS language for authorization. You can pretty much do, like Alpha and Cedar have a very good correlation between one another because they're both constrained. I think the major difference between the two is that Cedar does not have a hierarchy of policies. They're a flat list of policies. There's pros and cons to that. You don't have to learn how to build a hierarchy in Cedar, whereas you do in Alpha. But when you get to learn the hierarchy in Alpha, you can build policies more quickly. So I think it's partly a matter of taste. This is what it looks like if you wanted to visualize Alpha. Different tools have different visualizers. You can visualize OPA, and I'm sure you could visualize Cedar at some point as well. So that's not a biggie. And that brings us to event time authorization. In my book, I don't know if the tool is here. I hope not. It's putting a Band-Aid on the problem. I mean, doing governance as well, by the way, like doing provisioning and all that, it's kind of putting a Band-Aid on the authorization issue. But the truth is, you don't always have the ability to do the PAP PDP architecture that I was talking about. If you have a web-based app, no API, you're toast. So doing event time authorization to adapt your tokens to new threats. And by the way, it's not just about restricting the token. It could be expanding the token too, right? It's a good way to work. And there's a lot of stuff happening within OpenID shared signals that I recommend you go to. There was a talk this morning about CAPE that if you haven't seen it, you can check out the summary. That brings us to the authorization lifecycle. This is the way that you want to think. I said, don't do role engineering. Well, how do you want to think? Think in plain old English. Define your requirements. And when I say requirements, business requirements. I want to build an app for medical records. Great. Define the authorization requirements. Identify the attributes that are part of that conversation. Maybe it's the role. Is it a patient or a doctor? Define attributes on the resource. Whose medical record is it? Is it a test result? Is it a bill? Stuff like that. Author your policies. Choose your poison. Alpha, Open Policy Agent, or Rego, or Cedar. Deploy your policies, and then do access reviews. One thing that my customers tend to not do too much is analyze the logs. The logs are super interesting because they actually contain all of the information of who tried to get access and who did get access to the resources. When you look at authorization and you want to not build your own, but pick a framework that exists, whether open source or a vendor, look at these 10 different commandments. You want your authorization to be decorative. You don't want it to be hard-coded or opaque somewhere. You want it to be dynamic. You want to take into account location and time and evolving factors. You want it decoupled from the app, right? Because you want to reuse the authorization across your apps. You want to use ABAC and reback, like I mentioned before. You want it to be feature-driven by the business, not against the business. You want it to be agnostic. It should be able to tackle your APIs, but also your data, but also your web apps. It doesn't have to be technology-specific. Rego and OPA are a great example of how it was born in a technology-specific environment, but it's actually not technology-specific. It works well for infrastructure and other places. You want it to be scalable, of course, and you want it to be transparent, because at the end of the day, we're doing authorization to prove to the compliance team that we're not in trouble, that we're doing the right thing. So can we adapt to P*P architecture? That's the question that I have. It's an open question. I don't have a good answer. We want to convince all the software developers of this world to think in terms of P*P, but it's a tall order. People are still used to working in terms of roles and tokens and OAuth, so there's a lot of education still to be done. And on that note, just to summarize it, so we do have, I was joking in an earlier presentation that we have a lot of pyramids today. Well, here's another one. We have an authorization pyramid of admin time, runtime, event time. They're not mutually exclusive. You probably want to combine them together to have a solid fortress, if you will, and prevent my kid from eating too many cookies and ice cream. And there's a range on that thing. Before I leave you, with a couple minutes to spare for Q&A, here's a list of different things that you can check out, resources. There's lots and lots of material online by different bodies, including NIST. Go check it out. Thank you.
Thank you, David. Excellent talk, as usual. Folks, we have 2 minutes for Q&A. Raise your hand. I will bring you the mic. Nobody has questions. Excellent job, David.
Thank you.
Thank you all.